I will explain some applications of quantum dot technology to you. It was in 1900 that Max Planck published his first paper on quantum mechanics, and it is not really a new issue therefore. In spite of this fact, I notice in scientists, if not physicists, physicians and others, that often their ideas about physics end in the 19th century. At the same time, they use quantum mechanics instruments like magnetic resonance scanners or proton emission in the daily routine. In esoteric circles, quantum mechanics are also used in spite of a lack of basic knowledge. Therefore, I will recapitulate some necessary facts. Please keep in mind that this is bog standard physics and has nothing to do with subtle matter or astral bodies. Quantum mechanic phenomena are typical for molecular structures. If smaller than 20 nanometers, 1 million nanometers are equal to 1 millimeter. Their features are different from solid bodies. To get an impression of these dimensions, they are demonstrated in the following figures. A human hair with a diameter of 70 micrometers and a red blood cell with 10 micrometers. A bacterium with 1 micrometer, the bacterium at a magnification 10 times, a virus with 100 nanometers, also magnification of 10 times, in comparison to a quantum dot of 6 nanometers at a magnification 20 times, a dodecahedron composed of 13 molecules of silicon dioxide. We start with a phenomenon which is known since Galilei, 1640. He first had the idea of a pendulum to measure time. The first one had been constructed by his son. If you hang some pendulum clocks with the same length of the pendulums on one board, they may start uncoordinated to work. After some time, all pendulums, however, oscillate synchronously. This is called phase entanglement of oscillators or entrainment, a very common phenomenon. One example are crystal lattices, where atoms and molecules oscillate synchronously, causing invisible rhythmic antinodes. By backcoupling with an electric resonance circuit, the oscillation of the crystal, after reducing it, is used in quartz clocks to measure time. A crystal, being arrested by pressure to expand, creates an electric potential being proportional to the pressure, the piezoelectric effect. An electrical field is created. Beside of other technical applications, this is the principle of electric balances. If electric power passes the semiconductor, electromagnetic oscillations of energy bands, being close together in semiconductors, create partially coherent light. Another effect of synchronous oscillations in crystals is that light and other electromagnetic waves oscillate coherently in phase with each other, like in lasers. In contradiction, the light of a common old light bulb does not oscillate coherently. A big part of light extinct each other mutually and creates heat. You can say it creates heat and a little bit of light as scrap. In LEDs, a microcrystal is fixed to a semiconductor, forming a quantum dot. To get the same amount of light A LED only needs 10 to 12% of energy compared to a common light bulb. But you cannot warm your hands with it. It stays cold. It is possible as well to reverse the principle. If light passes the crystal, it creates electric energy in the semiconductor. Possibly this is photovoltaic in the future being much less expensive. The development is near to the technical application already. What does all this mean for animals and plants? Even cell membranes are highly organized, crystallite structures, the same as muscle fibers, retina of the eye, or collagen. Typical piezoelectric structures are all helical particles like DNA, keratin, actin, and collagen. There are a lot of quantum dots in organic molecular structures. Charges are distributed as well. Please keep in mind that a membrane potential of 20 millivolt at a distance of 5 to 10 nanometers is equal to a voltage field of some 1000 volts per meter. Highly interesting structures are microtubules. They are known for long during cell divisions as mitotic spindle. They are formed by 13 protofibrils. At a distance of 3 nanometers from the wall inside of the tubule, water is highly ordered. This means it is not conducting for electricity, but an excellent optical conductor. A possibility for the transport of information. This is much quicker than information transport by nerves with only 20 to 50 microseconds per meter. We know now that they extend like a web from nuclei via cell lumen, intercellular space through the whole body. Information can be exchanged at a speed of 1 microseconds per meter by this body-wide web. The famous mathematician Roger Penrose hypothesized in a speculative model how information can be stored in this web, explaining the still unknown phenomena of body shape and long-term memory, which could not be localized in the brain. A specific form of microtubules is alpha helical protein in the cell membrane. Living creatures are not an assembly of cells, which are little bags where biochemical reactions occur, an idea that can frequently be found in classical biochemistry. What is the origin of such a misunderstanding? In classical biochemistry, organs like liver or kidney are homogenized. After centrifugation, the cytoskeleton is discarded and the supernatant is used further. By this way, the idea established that the cell is empty and biochemical reactions are the same as in test tubes. We know, however, that a cell is densely filled with structures. Enzymes, for instance, fixed on microtubules and filaments show other kinetics than enzymes in a solution. A cytoskeleton is also bearing many semiconductors and crystalline structures and can create electromagnetic waves. All this has been lost in biochemistry. In most textbooks, you still will find the model of receptor-effector based on an idea of Paul Ehrlich. An effector fixes to a receptor and starts a physiological reaction. Since 15 years, we know that a big part of communication between cells and intracellular matrix is performed by electromagnetic waves, not only in nerves, brain and heart. Chemical substances act by their wave pattern, their fingerprint. These reactions are widely ignored in medicine, however. Unfortunately, Ehrlich's idea never gave an answer, for instance, to the velocity of the reaction to chemical signals. The idea was based on the observation that specific dyes couple to specific molecules of a tissue. The size relation would be a cell being a cathedral with, let's say, 100 receptors on the surface and effectors with the size of a tennis ball. In case of staining, the tissue first is embedded in a sea of dyes, the effectors. After draining and washing, only a few molecules remain attached. These, however, are not physiological conditions. A few molecules have to find a few receptors. This is impossible by Brown's molecular movement only. We meanwhile know that they use a trick similar to the one we use when we are searching for a car in a big car park. By using the remote control key and looking for flashing lights, we can find the car. Even without a coupling or before coupling, physiologic control can occur. Fortunately, many bioactive substances are semiconductors. Together with a nanocrystal, it forms a quantum dot. Non-coherent signals cannot extinct each other. The same is true for bioactive substances. They can act by their signal or by docking on a receptor. Using quantum dot technology, the signal becomes partially coherent. In other words, we need much less substance to get the same effect. This is important. Some substances are very expensive and others show unwanted side effects in bigger quantities. Just to give you an example, capsaicin, the pungent principle of chili, can restore apoptosis, the controlled suicide of cells. In cancer cells, this apoptosis lacks, and therefore they grow in an uncontrolled manner. According to animal trials from Chile, 3 times a week, 10 pots of the hottest sort, the habaneros, would be necessary. This, however, is unacceptable. By quantum dot technology, the quantity of capsaicin can be reduced to 0.25 to 0.75 milligrams per day, equal to 40 to 120 grams of sweet pepper.